Number 27, we've got g of x equals x squared minus 4 divided by x cubed plus x squared minus 4x minus 4. We're asked to find the x and or the horizontal and vertical asymptotes, the x and y intercepts, and any holes, and to sketch a graph of this. All right, so let's start off by finding the horizontal asymptote. So the horizontal asymptote here, remember that if the degree of the polynomial in the numerator is smaller than the degree of the polynomial in the denominator, and that's the case here. We have a second degree polynomial up here, a third degree in the denominator, so the horizontal asymptote is going to be 0. So, or in this case, g of x equals 0. It's going to be an equation for a horizontal line. All right, so now before we do the vertical asymptotes, let's factor this. Let's put this into, let's factor the top. So the top is going to be a difference of squares. So that's x minus 2 times x plus 2 is going to give us x squared minus 4. On the bottom, let's think about this for a minute. So we've got x cubed plus x squared minus 4x minus 4. This looks like something that we could factor by grouping. So we'll put those groups there, add these together. Let's factor an x squared out of this. We're left with x plus 1. Over here we'll factor a negative 4 out of that, and we're left with x plus 1. And so we get x plus 1 times x squared minus 4. And x squared minus 4 is a difference of squares. So this on the denominator here is going to be x plus 1 times x plus 2 times x minus 2. All right, so notice what happens here. We've got an x plus 2 on the bottom and an x plus 2 on the top. So those are going to divide to 1. And here we have an x minus 2 on the bottom and an x minus 2 on the top. That's going to divide to 1. So what we're left with is 1 over x plus 1. Let's graph this function. Notice, well, our horizontal asymptote is going to be at 0. Our vertical asymptote now is going to be at x equals negative 1. Just set that equal to 0, and that's what that's where our vertical asymptote is going to be. So that's right here at negative 1. And then let's see, the y-intercept is going to be, let's plug in 0 for x, we get negative 4 over negative 4. So the y-intercept is going to be at positive 1. And the x-intercept, well, there's not going to be an x-intercept because our asymptote is right there on the x-axis. So we have a y-intercept that's going to be at the point 0, 1. All right, and then we can draw this graph like this. Notice that this is just the parent function 1 over x just shifted to the left 1, and that's all we've done here. Now we're left with the holes, because remember, we weren't given this function, we were given all of this. So even though we were able to divide out the x plus 2 and the x minus 1, that those divided to 1, and so we were able to get rid of those out of our rational function. there's still a problem that if we plugged in either 2 or -2 into this function, we'd get 0 on the bottom. We'd get 0 on both the top and the bottom, and that's going to be an indeterminate form. And so that's where our holes come from. Remember, we talked about those as being removable discontinuities. So we're going to have a removable discontinuity on this graph at the point x equals 2. So the holes, we just put holes over here. The holes are going to be at x equals 2 and x equals -2. So if we go over here where x equals 2, right there, we're going to have a hole. And at x equals -2, that's going to be about right there. We're going to have a hole there as well. And so that's our graph. We've got a vertical asymptote at x equals -1, a horizontal asymptote at f of x equals 0. We're going to have a hole at x equals 2 and another hole at x equals -2.